Hi, Assalamualaikum and very good day. I wish to Dr. Rashidah Hanum. Okay, today me and my friend going to present about Industrial Building System IBS. Our case study is in Seri Jati Apartment in Shah. In this video presentation, we'll be presenting by 5 person, which is Isma Zafri, Amirul Ashraf, Luqman Saleh, and me, Nur Alia, and lastly is Munira.
Assalamualaikum warahmatullahi wabarakatuh. So I'm going to present about concept and framework of IBS. Introduction of IBS. The Industrialized Building System (IBS) is a construction method that employs component manufacture in a factory setting. IBS is also known as prefabrication, off-site construction, and modern construction method in some countries (MMC). There are two types of IBS system. The first one is open system, refers to the standardization of component that allows for interoperability and interchangeability between different manufacturers. The second is closed system, refers to components that can only be used in certain projects by specific manufacturers. Advantage using IBS. First is less construction time. IBS takes less time to build since precast elements can be cast in the factory and foundation work may be done on site at the same time. And the only work done on site is the erection of IBS component. As a result, the building gets occupied sooner. Second is cost saving. IBS component formwork is built of steel, aluminium, or other materials that allows for repeat uses, resulting in significant cost saving. Third is less manpower use. When IBS components are manufactured in a plant, increased machine utilization is permitted and labor consumption is minimized, leading in labor cost reduction. And the last one is optimal material utilization. The use of machine in the production of IBS component result in a better level of precision and accuracy, as well as a reduction in material waste. Disadvantage using IBS. First is problem joint. Water leaking is a common issue in building constructed with IBS. This issue is especially visible in Malaysia, where rainfall frequently throughout the year. Second is requires advanced technology and knowledgeable operators. Complex plans that must be well coordinated and operate by experienced operator are frequently used in prefabricated systems. If just one part fails, the entire production line will come to a halt. Third is accessibility of the site. One of the most crucial aspects of IBS deployment is site accessibility. To transfer IBS component from the plant to the job site, IBS require appropriate site accessibility. And the last one is large working area. IBS-based building construction necessitate a vast working space for the factory, trailer, tower crane, and IBS component storage. Furthermore, most building sites, particularly in cities, are frequently congested and unable to provide the necessary space. Next is IBS workframe. The first step is design and planning. Second, fabrication of component in factory. Third, transportation of component. Next, assembly of component, and the last one, installation. So we are going to the component of IBS. The first component is precast concrete frame. In this project, IBS has used precast concrete frame building. There are several reasons why this method was chosen over the traditional method. The internal flexibility of the frame system is particularly advantageous, as the huge area may be used for a variety of purposes and simply modified or adapted according to need. The components are cast and cured in a factory before being transported to the job site and constructed as this component. This process offers more advantage than simply pouring concrete on the job site. The precast concrete frame provides a high strength, robust, durable, and sturdy option for any multi-story construction. The starting of the entire process not only will save time, but also allow the construction process to continue even the inclement weather. Second component is precast staircase. In this project, the sort of pre-printed ladder employed is one that requires a complete flight with the requisite number of steps. The landing, support point, and some insulation are all included in this precast staircase method. There are individual wall panel components. This technology requires no installation or bracing during erection and is extremely flexible and precise in its output. The third component is precast column. Why this component used in this project? Because they are basic in form, detail, and construction. The selected precast column in this project use single floor-to-floor corbelled pieces, which match the repetition characteristic in this apartment design. Initial column profile and edge column profile are used to support the wall in this construction. And the next component is precast beam. Precast beam are designed to be simple and practical. The spandrel L shape and the latch invert T profile are used in this project. They are made to be continuous in order to improve future loads. The precast floor component rests directly on the inverted T protruded latch. The next component of IBS used in this project is precast slab. Side cast concrete fill and reinforcing steel are used to connect hollow core slabs to supporting components. In addition to the concrete fill used for connection, the slabs are usually topped with a side cast concrete topping. The topping improves the fire resistance and sound insulation of the floor by providing structural integration of slab sections. It also serves as a leveling bed, which is useful for units with uneven camber. When utilized, topping is typically 2-inch thick and strengthened with weld wire reinforcement. And for the last component of IBS used in this project is steel framing system. The whole is kind of roof truss was used in this project. Steel roof framing is more expensive than timber roof structure, but it is also more durable and requires less care. Steel roof framing, unlike timber roof framing, does not require treatment to resist natural substance. Steel roof framework is environmentally friendly due to its ability to be recycled.
I'm going to present about future of IBS component. Here is the future IBS component. First, finishing and dimensional. During production, a planned production environment allowed the company to correctly implement several risk management techniques in order to fulfill specific or national standards. Second, variety in design. Pre-skating allowed for more specific strength and the use of analogous shape and size on a constant schedule to save more money. Third, quick erection at the preferred destination. Especially in this quick erection, basically if we compare to the traditional method and IBS, I got a comparison, which is precast component arrive at the site and ready to install. But for the traditional, we need to did work step by step. Next, I'm going to present about suitability of IBS. What is suitability of IBS? Okay, the suitability of IBS is to examine its potential and system might be used as an alternative for the traditional system which has already have a significant presence in Malaysia. It was not only efficient in speeding up the construction of housing development, but it also increased their quality. And lastly, to revert to the IBS definition, is basically a building method in which components are created in comfortable condition with either on or off-site. By referring to Dean in 2009, he stated that the development of IBS, on the other hand, have never extended outside of this time frame. The industrial is presently updating its building approach as a result of a failure of early complex system, and also he mentioned that also can improving building efficiency and productivity and minimize occupation safety and health concern. Also, he stated that can reduce issue for skilled worker. Lastly, is a fabrication process of IBS. In this slide, I will attach a short video how the fabrication process of precast concrete.
Plants and gain first-hand experience on Oldcastle Infrastructure's precast manufacturing process. Follow along as we take a closer look. The process starts with engineering. Every product is engineered using the latest design tools, and detailed drawings are created using a 3D computer-aided design process. Once design drawings are approved, they are sent to the factory floor and used to monitor production. Now it's time to assemble the rebar cage. The first step in this process is the cutting and bending of the steel reinforcement. The correct rebar is selected and shaken down off the storage rack and is then cut and bent to the exact dimensions needed to fit the design requirements. Next, the bars are assembled and tied together to form the reinforcement cage. Rebar wheelchairs are used to help position the cage within the form and to ensure proper clearance of reinforcing. Once the cage assembly is complete, we can begin to prepare and clean the form. Oldcastle Infrastructure uses a variety of steel forms, which are built to last and will maintain exacting tolerances for more than 30 years. At this point, all openings, cutouts, or embedded items are secured to the form. Then a form release is applied to each surface to ensure the final product can be easily lifted from the form. Now that the form is prepared, the overhead crane is used to pick and place the cage onto the core of the form. Care is taken to ensure that the reinforcing cage is stable for transport to the form. Once setup is complete, a certified quality control technician will conduct a pre-pour inspection to ensure conformance with the approved shop drawing. Upon satisfactory completion of this inspection, the technician will sign off and flag the form indicating approval to place concrete. Oldcastle Infrastructure uses a variety of certified raw material sources, including cement, coarse aggregates, sand, and chemical admixtures, which are carefully selected and mixed according to the specific design requirements. Each Oldcastle Infrastructure precast factory has a concrete laboratory used to conduct routine raw material testing and control exact quantities for each batch. This is especially important when using high-flow self-consolidating concrete. The lab collects sample cylinders used to check compression strength and verify quality of each batch. Once the materials are properly mixed, the self-consolidating concrete undergoes a variety of additional tests, including a spread test to verify the mix has the proper flow and no segregation of the aggregate. The approved batch is transported in a bucket via an overhead crane to the product form on the production floor. Concrete is placed into the form from on location, and care is taken to allow the concrete to float without entrapping air voids. Once the form is filled, the top of the form is screeded off and the specified finish is applied. Once the concrete is placed, the curing process begins. This may include tarping the product overnight in order to capture the heat from the hydration process. The controlled environment of a precast factory enables the product to properly cure and reach the full design strength. Once the QC technician confirms that the product has reached the desired strip strength of 2,500 to 3,000 psi, then the stripping process may begin. This involves opening the outer jacket, collapsing the inner core, attaching the lifting devices, and removing the product from the form. Once the product has been removed, it is then cleaned and the post-pour inspection is conducted. If all design dimensions have been maintained and no visual defects are noted, the QC technician will sign off. The final product is then labeled and transported to the yard. Care is taken to make sure it is stored on proper dunnage as it awaits the customer demand. When the customer is ready to receive the order, the product is loaded on a truck and properly tied down for shipment and delivery to the project site.
Assalamualaikum warahmatullahi wabarakatuh. I want to explain about the connection detail and the installation process. Okay, first we move to the first one is the pad footing. Okay, for the installation process, we have to excavate small site for pad foundation, and then we must create a formwork before we install the starter bars. After all finished, we have to pour concrete into formwork as column stump. Okay, next we move to the precast column. For the installation, we have marking axis on the footing and check whether the anchor bolt are precisely concrete. Then the nut should be screwed on the anchor bolts and washer placed on footing. Column raising into plane vertical position. The gap between the top of the footing and the column left about 50 mm or 10 mm. The column should be put on the bolt and erected the washer. Column should be level by the lower nut and adjust according to the axis of the building. Then secure it by putting the upper washer and tighten the nuts. The column footing junction assembly should be hermetically sealed using formwork. Concreting should be carried out via pumping the concrete mix using an aggregator pump through the opening at the column side. Okay, next we move to the wall panel. Okay, for the installation, first wall section are carefully removed from the delivery truck. Each section is safely transported to fence line. A wall section is the lineup with the protruding steel support. Once the wall section is over the steel support, it is lined with the preceding panel and the rigging is removed. Next, we move to the precast beam. For the installation, precast beam resting spot should be cleaned up and column console attitude should be checked before installing beam. Elevation of the beam from the ground with the correct lifting chains and length. The beam needs to hang horizontally. After the item is raised to a correct height, the item should be converted to a hole above column bolt with the help of rope. When the item is carefully lowered, installer on installation area will adjust the item to support it on console equal to column distance about 2 cm. The column bolt should be grooved with concrete prior to installation of floor which tighten beam. Next, the precast staircase. For the installing and landing on temporary frame of support precast concrete stair. The unit is released immediately by adjusting screw jack within the frame members from the grid hook and is into exact position. However, elevation fits into two temporary frames. The frame fits near the stair to give maximum space to the foot on the tread. Assemble the staircase landing with a floor slab. Okay, we move to the last item is the roof steel framing. For the installation, to carry trusses to their place using crane. To prevent damage, it must be tightened from the top cord panel. Ceiling placed equally far from the central truss or wall. About a third to half the length should be removed from the sling. At no time should the angle on the sling leg be more than 60 degrees. For a roof span over more than 9,000 mm, the screw bar or strong back will be used for prevent warping and damage to the truss. Mark truss position on the top plate as a reference to the roof framing layout. The gable and truss installed. Once the gable is in position, wear a head tag screw through the bracket attached to each heel connection. Temporarily straighten and straight the gable truss. Install the net truss as described in previous step. Install purlin at the end of the flush toward pads. Purlin sit on top of the gable and set himself in front of the first standard gable. Fix purlin to the lip of the first standard truss with tack screw. Fit the purlin down to the gable truss with the tack screw.
Hi, my name is Munir binti Ibrahim. For the modular component, IBS is a construction delivery system with structures produced 60 to 90% off-site and shipped, assembled, and installed to the final building site in a factory-controlled environment. Modular system may significantly shorten the overall construction time and minimize construction wastage. First component would be precast column, which consists of 3 types of columns, and the overall unit of column is 45 units. Then the precast floor slab consists of 6 types of precast slab with the overall unit of 48 units. Next, the precast beam consists of 107 units of H-beam and 142 units of intermediate beam. The precast wall panel consists of 60 units of external wall and 30 units of internal wall. Furthermore, the precast staircase has 6 units of 18 steps which made of concrete. The prefabricated openings consist of 24 units of windows and 58 units of doors. Last but not least, prefabricated steel roof truss would have 63 units, and that is all for the schedule of modular components. Thank you.
Okay, for my part is IBS core for Seri, Jati, Aparment, Shah. IBS core is systematic and a structure evolution system that may be used consistently to measure the use of IBS. The higher IBS score reflects a reduction in site work, lower waste, material less, a cleaner atmosphere, greater quality, cleaner and more secure work, faster design and reduced general costs. For the formula, coverage formula, area divided by total area, and IBS score formula, which is coverage times by IBS factor times by IBS point. For the total is structural system score plus wall system score plus other simplified construction solution score. The maximum of IBS score is 100 points. For part 1 is a structural system. The structural system for this building have 7 components, and the total point of the 7 component is 39.10 point. Okay, this is part 2. Part 2 is a wall system. For Seri Jati Aparment Shah have 3 wall system, which is internal wall, external wall, and common brick wall. For the total IBS score for wall system is 18.80 point. Okay, for the part 3 is other simplified construction solution calculation. For the part 3 have 2 sections, which is standardized component and repetition of structural layout. For the total point of the part 3 is 24 points. For the total IBS score for Seri Jati Aparment Shah is 39.10 point plus 18.80 point plus 24.00 point, which is we get 81.9 points from 100 points.
In conclusion, we acknowledge the value of learning and are conscious that, especially when a project involves fast development and a limited time of construction, the IBS systems are extremely lucrative. Instead, based on IBS score calculation, a few of factors have to be taken into account in order to obtain a high IBS score. First thing is the design must be modularly coordinated, MS 1064 compatible. Then developers and contractors should intend to adopt IBS from the start, including any simpler building construction techniques. Then, where feasible, prefabrication need to be taken. Then minimize work intensive, such as brickwork and plastering. And also, developers should favor IBS construction in order to clean the project sites, reduce labor intensity, and improve quality. Last but not least, contractors must continually consider more efficient methods. Thank you.